Compound interest. Simple interest from the previous lesson introduces the concepts of principal, accumulated capital, interest rate, and term. In the real world, interest that's paid or received is usually based on a compound interest rate. This means that you pay interest on the interest you owe, or you earn interest on the interest that's owed to you. You could get into a philosophical debate about this as to whether it's right or wrong to be charging compound interest or not, but if you think about a $1,000 loan that has a 2-year term, assume for a moment that it has a 7% year interest rate. That means that after the first year, you owe 7% of $1,000, which is $70. However, because the loan hasn't been paid back yet, you now owe $1,070 going into the second year of the loan. So the amount of money that you've effectively borrowed has increased. So the interest owed in the second year is charged on the principal and the interest from the first year. This process repeats each year with the interest accumulating with the principal. Let's follow through on the rest of that example with the $1,000 loan and the 2-year term with 7% interest rate compounded annually. First, we'll calculate the amount owed after 1 year. So C1, or the amount owed, is equal to the initial amount plus the initial amount times 0.07. So that's 1,000 plus 1,000 times 7, which as we said is going to be $1,070. Now let's look at the amount owed after year 2. We start with the same formula, but this time we're dealing with the year 2 capital, so C2 is equal to the initial capital, which this time we're using the initial capital, which was the output capital from year 1, plus that same year 1 capital times 0.07%. So we get 1070 plus 1070 times 0.07, which gives us 1070 plus 7490, and now we get 1144.90. So if you're lending money, it's in your best interest to have the interest owed calculated frequently and added into the total owing, compounding, because you make interest on the interest owed. Compound interest serves the interests of the lender. Let's take that same example, but the interest rate will be half of 7%, 3.5%, and it'll be calculated and compounded twice annually or every 6 months. So a $1,000 loan, your 2-year term, 3.5% per 6 months, compounded every 6 months. So the amount owed after 6 months, we take that same formula, C1 is equal to the initial C0 plus C0 times 0.035, and we multiply that out, and we end up at 1035. Now the amount owed after 12 months, C2 is equal to C1 plus C1 times 0.035. Now we look at it after 18 months, we follow through that process, and when we get to the end, we see we've got a value of 1147.52. So by compounding it twice a year, every 6 months, we end up with a higher value than when we first started with the compounding just at 7% compounded annually. So in the earlier example, where we had a rate of 7% calculated and compounded annually, the total amount owed was $1144.90. When the interest rate was cut in half and calculated and compounded every half year, the total amount increased to $1147.52. So a higher compounding frequency clearly benefits the lender. When interest that's earned over a period is added to the capital before interest is calculated for the next period, we refer to this as compound interest. Effectively, interest is being charged on interest. When we've been doing the calculations up until now, we've been doing them year by year, and each year calculation was based on the previous year. But you can see as you go through that it's possible to relate your final number, so your accumulated capital, to the initial capital number, simply by using the term of the investment as the exponent. So of course, we can generalize this solution to say that the accumulated capital is equal to the initial capital times 1 plus I to the exponent n, where n is the term of the loan or the lending, where n is the term, and n and I must be in the same units of time. So n can be in months, half years, or years, days, minutes, whatever. Of course, we can also discount with compound interest just the same as we did with simple interest. Thankfully, there's a formula for that as well. The initial capital is equal to the accumulated capital times bracket 1 plus I to the exponent negative n. So if you remember, negative n means 1 over. So we can also rewrite this equation in another form, which is initial capital is equal to the accumulated capital divided by 1 plus I to the exponent n. We can reorganize the equation to isolate any one of the variables in it. So we could find the term of the compound interest investment or loan as long as we're given all of the other variables. We could start off with the equation for initial capital and reorganize it, going through some algebra. Eventually, we get to the point now where we've got an n as an exponent. In order to solve that, this is where our knowledge of logarithms comes in. We can take the log with a base of 1 plus the interest rate of the accumulated capital divided by the initial capital. That will give us the term of investment. You'll also remember from our previous knowledge that we can convert that to be working with base 10 logs rather than the special log of 1 plus I. Also, remember when we learned about logarithms, we said that the log base a of b is equal to the log base 10 of b divided by the log base 10 of a. Most calculators have the log base 10 function, so this makes it easier to do. That allows us to rework the equation on the left so that you can do it more easily on your calculator. So ultimately we end up with n equals the log of the accumulated capital divided by the initial capital, and all of that has to be divided by the log of 1 plus I. We can similarly find the interest rate of the compound interest investment or loan. Again, we'll start with the very first equation, this time from the accumulated capital, and reorganize it. This time we're going to work to isolate the I from the equation. In order to do that, we have to find the nth root of Cn divided by Co, and then subtracting the 1. So ultimately we end up with an equation that says I is equal to the nth root of the accumulated capital divided by the initial capital minus 1, where n is the term of investment. So in summary, in a compound interest scenario, you can find one missing value if you're given the other variables. You can calculate accumulated capital by using this formula. You can calculate the initial capital using either of these formulas. They're just different presentations of the same formula. You can calculate the term, or you can find the interest rate.